This year, we've already talked about the possibility of living comfortably on Mars, as one does, with the help of mushrooms, as one does. And today, let's dive into some other ways of using and playing with organic material that could maybe be our future.
Okay, so I'm guessing it's not more mycelium, it's going to be something else.
Correct, because enough of mushrooms for 2022 already, Conor.
No such thing, but anyway.
Okay. Today we're going to talk to two different people who in their own separate ways think that genetic modification is the future.
And that's what matters, I guess, on today's episode.
This is Jacob Moulenge.
I'm a plant scientist, and currently I work at a company called California Cultured.
So what exactly are they culturing?
Well, the company is all about the new age of sustainable and ethical food.
We're interested in utilizing plant cell technology to start making some of these high-value food products that we so enjoy, but due to climate change and other ethical reasons, are becoming more and more tenuous to sustainably get for consumers. So right now, our big product is looking at chocolate, of course, grown by cell culture. So that's sort of what I'm doing right now.
Okay, so there's a theme emerging here. We've talked about meat culture, we've talked about mycelium culture, we have an episode on cultured seafood, so we're talking about cultured plants here, and he wants to change specifically chocolate?
Correct. And to do that, we looked at where Jacob has come from. Though he is Danish, he was raised in sunny California.
I love California. I've lived in California for a long time. I live here with 40 million other people.
He says he and the other 40 million people in California have started noticing some stuff.
Okay, all right.
Yeah.
Just all together. Oh, what was that? Yeah.
Yeah. And as a child, he was told that these kinds of things wouldn't happen for another 100 or 200 years. So
and
there's
it's not
this
like,
acceleration.
Where's my jetpack? It's climate change.
What's
and so
happening
on.
to our planet?
Mm-hmm.
It's not raining anymore here, right? And we're a wealthy place in a wealthy country, and we can deal with it. And even we are struggling to deal with it.
So the biggest thing is climate change, population pressures, and so on, I imagine.
That is a huge part of why he started working at California Cultured, yes.
Climate change is affecting our agricultural production in a way that I don't think we fully grasp. And it's going to change the way we do agriculture completely in the next 20 to 50 years, depending on how fast, it continues to devolve, essentially. And so one of the big issues here is that things like coca, which is right now, or cacao, sorry, is grown primarily in West Africa right now, at the expense of rainforest, and specifically, more importantly, virgin rainforest.
You only have to look at somewhere like the Ivory Coast, according to Jacob, to see the reality of climate change on rainforests.
They've lost up to 80% or 85% of their rainforest since the 90s.
Okay, that's insane. I just didn't even realize it was that big a decrease.
And you spent your youth in areas...
I did. I lived in the tropics for most of my early years, and the rainforest was part of my childhood, and the fact that it's disappearing is a real tragedy.
And shocking.
And really, really important land that needs to be maintained as it is so that we can mitigate the very worst bits of climate change.
So I get the climate part, but you sort of hinted that there's more to it than just climate with California Cultured for Jacob.
Most certainly. So Jacob was describing one of the biggest problems we have right now is that a lot of agriculture is clonal based, which in turns mean that there's low genetic diversity.
You also have increased or changed geographic distributions of pests and diseases, which means that you have decreased genetic diversity, increased pathogen or disease loads or pest loads. And so taking that together, we're basically looking at a future where we cannot grow the things that we need to make chocolate in the field.
Okay, so they're, the plants that we grow commercially are all the clone, basically.
Right.
Okay.
Bananas. It's all the same
It's
banana
all the
we
same
ate.
banana, right?
Yeah.
Okay. And so what he's saying here is that chocolate's just not worth it.
Kind of. And, of course, it's worth focusing on rice, corn, wheat, the staples. We'll die if we're not eating those things. But when it comes to chocolate, maybe there's another way.
Chocolate is unsustainable and unethical as it's currently being done. And it's because it's a huge, complex supply chain. And one of the biggest problems is that the urbanization in West Africa, where it's primarily grown, has basically decreased the labor pool. So children and slave labor are being driven and used to harvest the chocolate that we eat and love. And that's a big problem. So you take the real daunting challenge of climate change, and you take sort of the longer term labor challenges. And also, if you're a consumer, you should be doing right when you're eating a piece of chocolate and not doing wrong. And I think that idea, is really tantalizing for the consumer to really be pushing. If we could have a product that really challenged those two issues, and that's what we think we can do at California Cultured.
Okay, that's cool. Of course, we talk about bioprocessing all the time here at Cytiva. We love bioprocessing, that you can take a cell culture and grow protein or cells and extract from it through harvesting, whatever you might want to grow and express in that cell culture. But food is turning into a real, theme this series. And of course, one of the challenges is public and consumer perception of lab-grown meat, as it's been described and so on. So, is this going to have a challenge for the consumer when we're talking about chocolate that doesn't come from a cocoa bean?
This is a really challenging topic because as a scientist, I love GMOs. I think GMOs are the future. I think there's no future in which we survive and we're not all eating GMOs on a daily basis. That's the future, full stop. Because traditional breeding cannot keep up with the change in the climate. The rate is too fast. We need to be able to develop things much faster than we currently can. That said, people don't really want to eat GMO products. You can't change, you can't move mountains sometimes, and that's just the way it is.
This is where Jacob's love for plants kicks in.
They are immortal and totipotent. And so what that means is that if you give them the right combination of things, nutrients, hormones, they'll grow literally indefinitely. They have no timer on their cells, which is very different than, say, mammalian cells. You can take a cell from a living cell from any part of any plant, literally any part of any plant. You can put it on a petri dish and you give it the right sugars, hormones, and nutrients. You can turn that cell into anything else, any other plant cell.
So he used a word there that we're familiar with from stem cells, totipotent. It's difficult to say, but
no, I had to ask him about it.
Mm-hmm.
This is not in my everyday language. And it literally means, a direct translation is it is capable of giving rise to any cell type or complete embryo.
It can become anything you want it to become. And what that means is that we're basically taking cells that have already become mature tissues. We're de-differentiating them. And that's really the key concept, is this de-differentiation step. And then through de-differentiation, we basically bring them back to a stem cell-like identity. And then we ask these stem cells to divide indefinitely. And then if we want them, we can add small molecules or stressors, and we can push them metabolically in certain directions that can then help us get some of these chocolate flavors or some of these special metabolites in chocolate that we're interested in.
But chocolate is already a plant, right? So what's he talking about? Is he talking about creating a different kind of chocolate plant?
Yes.
So does it taste like chocolate?
There is a scientific answer to that.
No way.
Because they are measuring scientifically how taste can be compared. You think that taste is subjective. It's not. It's scientific.
Not. So there's a chocolatometer?
And it has to get to 12.
Yeah, it's 12. What is it? Is it 12 Reese's Pieces on the chocolatometer? What's the scale here?
That's what's crazy to me, is that we are able to make a equivalent product to a lot of the chocolate that's available out there. Maybe we can't compete quite yet with the premium, super special chocolate quite yet, but I think that in terms of a lot of the bulk chocolate that's available out there, we are at par, if not better at this point. We've gotten some chemical analyses back, and it's crazy. We've actually been able to find that the cultivars that we have grown in cell culture, their cells that we're growing strongly resemble the cultivars themselves grown in the field. And so I think that's a really, really powerful reminder that we can get there, and we just need to keep pushing at it.
Okay, so this is pretty cool. This is guilt-free chocolate in every sense of the word.
For you.
Okay.
But you know how I am.
I know. So what about the chocophobes?
Turns out I'm not alone. I asked Jacob this same question.
Actually, secretly, I'm more of a creme brulee guy.
I loved that. I love that.
That's just brilliant.
He's devoted to chocolate in
and
his
he's a
work.
creme brulee guy.
Yes.
Yeah. That's we should talk about creme brulee one day.
Oh, do let's.
Okay.
Now it's time to hear from somebody else who sees genetic modification as the future, but this time the future is cosmic.
Okay, so my name is Natasha Hafman. I am a researcher at the University of Florida. What I do is a myriad of different spaceflight experiments, plant biology experiments, plant molecular biology experiments, basically to understand, in essence, how plants respond to the novel environment of space.
Natasha rivals Jacob in her love for all things plants.
Plants have had their entire evolution on Earth, where they've basically developed all sorts of mechanisms to deal with changes in their environment. So plants, unlike us, can't leave and walk away. So they have over, millennia have developed mechanisms to deal with bright lights, to deal with heat, to deal with pests, and to deal with all sorts of, environmental stresses.
During her work, Natasha wanted to see what happens when you take plants away from these evolutionary environments that she was talking about and just brings them into some new place.
Okay, so we're not talking about taking plants from outside and bringing them into your living room.
No.
We're talking about, I'm going to guess,
them in a rocket.
Stick them in a rocket, shoot them to the sky.
That's right.
What happens when there's no gravity? How do they respond? Is the response the same? Is it slightly different? Or will they just stress out and die, And so basically over the years, decades actually, we've grown plants in space. We've learned that they do well, but they also experience different stress. And stress doesn't have to have a bad connotation. Stress can be just a different way of dealing with their new novel environment.
And an example now of Natasha's work is looking into microgravity light.
Plants grow on Earth. We have light, and the roots grow away from light. Basically, they are called negatively phototropic. They go away from the light sources, and gravity helps them sink down to the gravitational pull. And so in microgravity, you don't have that gravitational pull. What happens is they use light as the next best cue to figure out their environment. And so these are little things here and there that we are learning and that we are understanding. And then also now we're looking at the genes, what kind of genes are turned on and turned off in the spaceflight environment, and how we can understand the pathways that they're using, and so that we can, figure out better strategies to help them adapt to this novel environment.
So the end game here is what? The sort of being able to grow plants on interstellar voyages in, like you see in science fiction sometimes, in like movie series like The Expanse
Martian.
or The Martian. Is that right?
Humans are just really curious beings, right? We want to explore, we want to go beyond the reaches and as far as we can travel. And so we will be exploring our universe. We'll be exploring our solar system. And we want to know, when we do go to a different planet, what's the main thing we need to take with us? That's food. And plants, they are just so remarkable because not only do they provide us with food, they also provide us with oxygen, and they help create a sustainable environment for us to thrive and live in. And so they are so versatile.
So we have been, as humans, growing plants in space. There is a field of astrobiology. So, where are we with that now?
We've been growing them in space for decades. From wheat to rice to potatoes to, oh my goodness, so many different stuff like basil and Arabidopsis. So Arabidopsis is basically what we use in the lab in general because that's kind of like the mice, the white mouse of the plant world, basically. We've grown a bunch of plants, and astronauts have only in the last decade started consuming them. First, we need to know, can plants survive in the spaceflight environment?
Okay, so let's get back to the work that she's doing on modifying plants for this.
Sure. And I wondered if Natasha could foresee ever taking a bioreactor up into space, as we at Cytiva would so much love to see that go into a rocket and be shot out into space. To maybe grow food in a sterile environment, grow medicine in a sterile environment, anything. So like Jacob, Natasha shares the philosophy that anything is possible if you put your genetically modified back and sweat and blood and tears into it.
You've just got to try it, right? Yeah.
Genetically modified food is sort of the way to go, only because, if we want to grow plants on Martian regolith or lunar regolith, we are now realizing that there are a lot of components within those regolith that does impact how plants grow, their health and everything. And so we have to be able to kind of, looking at all those genes that we are studying now for decades, figure out what will help them in those environments. And then by enhancing those genes, we can, allow them to grow healthily and be productive for all the food. So genetically modified food, plants are definitely where we are headed. There's still a lot of things that we have to iron out. Like, for example, if we do create a genetically modified variety of plums, we need FDA approval, we need all sorts of paperwork, and all that kind of stuff still are in the works. We don't really have a sound pipeline to get those things, off and running just yet. So there's a lot that we have to still kind of work around with.
Before we said goodbye, Natasha wanted to emphasize that this whole thing is an ongoing communal experiment. And, she's totally comfortable in that environment.
Fantastic.
Nothing is set in stone just yet. Everything is still very dynamic, and people are having all sorts of conversations about how to improve growth methods, how to select for crops, how to select for natural varieties instead of genetically engineering them. There is so much that this community is trying to figure out. And so there might be certain things that one person might drive towards, but somebody else is working on another direction and alternative. So it will be fun. It'll be exciting to see what the future brings.
All right, so if this were to come down to a showdown between mushrooms and plants, I'm going to go with plants. Plants are the winners.
Okay. But so look, the honest truth is there would be no plants had we not had mycelial gloop at the very, very beginning.
Chicken and egg,
so
really.
It's, yeah,
The
exactly.
Gloop, it's the gloop that wins?
Yeah, the mycelial gloop is going to win every time. So we'll have to agree to disagree on that one.
Okay. Our executive producer is Andrea Killen, and this podcast is produced with the help of Bethany Grace Armit Brewster, who maybe should get one more name for the next episode.
That's probably a good idea, isn't it? Editing and mixing is by Tom Henley and Banda Productions.
My name is Dodi Axelson.
I almost read your line. And my name's Conor McKechnie. Make sure you rate us on Spotify or whichever platform you use. And we'll see you when we come back with another episode of Discovery Matters.
Hey, if you can't get enough of plants or mushrooms in space, we highly recommend Gardeners of the Galaxy podcast, hosted by Emma the Space Gardener. She guides you as you explore cultivating the cosmos, planting planets, and sowing seeds in space.
Yeah, try and say that 3 times quickly. So check it out on your preferred listening platform.
Gardeners of the Galaxy.